This is the second part of our 6-2 pre-calc notes. So in this section of our notes, we're going to be finding the inverse of a 3x3 matrix, and we're also going to be looking at determinants. So if you have our notes handout, this is like page 3 and 4, so like the second stapled page, both sides. So we're on example 3 right now. So remember from what we already looked at in part 1 of our notes, if I take a matrix and I multiply it by its inverse, I get the identity. So what that means is that if I have A and I augment it with the identity matrix, so remember that means that line, this is instead of having like our answers for X, Y, Z, this would be that actual matrix. Then I could solve for my inverse matrix. So instead of solving for X, Y, Z, I'm solving for that entire identity matrix using Gauss-Jordan elimination. So using Gauss-Jordan elimination. So what that means is I'm going to have to take my entire matrix. So I'm using all of A. I guess I just slide this over a little bit. So 1, -1, 1, 0, -2, 1. So I'm going to just take this whole matrix, and instead of augmenting it with answers like we did before, we're augmenting it with this entire identity matrix. And now we're going to try and get our ones and zeros. We're going to try and get Gauss-Jordan on this side. And then our other side, our answer, is going to end up being that entire inverse matrix. So just like before, we look at our columns first. So in my first column, I already have a 1 and then a 0 in row 2. So this is the only number that needs to go in my first column. And it looks like I'm going to have to use row 1 to cancel that out. So I'm going to do 2 times row 1, and I'm going to add row 3. So let's just go ahead and do multiplying. Make sure you're multiplying all the way across, even all 3 of these numbers, not just the first one anymore. And we'll add those together. And so this is going to be my new row 3. So you do not have to write this down, but I know it's really helpful to my students. That's my new row 3. So now that I've done everything in that column that I needed to do, I only needed to cancel out this number, I rewrite my matrix. So every time I finish with a column, I rewrite. And I didn't do anything with row 2. I only changed my row 3. And my row 3 is now -5. Let's see, 2, 2, 0, 1. Okay, so now I'm looking at column 2. So in column 2, because I only want the ones and zeros, I have a 1 in this first row, but I need this to go away. And my second row, I need something here, but I need a 0 over here, so I'm going to leave that for now. I know that this -2 is not the one we want, but in order to make this a 1, I'd have to go through and divide all of them by -2 and get fractions. So you're going to find that we really don't want to do any dividing until the very end. So we need to not worry about the fact that this is a -2 instead of a 1 for right now. We're only really focusing on getting the zeros. So do not worry about getting the ones and zeros, just worry about getting the zeros. So now I'm going to take my row 1, and it would make sense to match this with row 2. So let's do row 1 plus -2 row 2. Oh no, we'd have to do -2 of the row 1, wouldn't we? Plus row 2. Got that backwards. So let's go ahead and multiply that. And then the middle row, so row 2, I'm just writing down the way it is. And add those together. And again, I have my 0 for my second term, or for my second element, but the first element in that row is a -2, and I know it's not a 1. My students were really bothered by that -1 going away. All we're worried about right now is getting the zeros where we want them. So don't worry about that. So now I'm going to use row 3. I'm going to have to use row 2 and row 3 here, because if I used row 1 at all, I would get a 1 at the middle of it. And so I can really only use these 2 rows. So I'm going to have to look at, let's see, let's say like -5 times row 2 plus 2 times row 3. They're going to have to both be 10s. I know that's a little bit bigger than what we normally have to deal with, but it's going to be fine. I don't like this isn't lined up very well. Oh, I guess I got to move my screen up. 0, where was I at? 2. And then we're going to add those together. And now, because I want a 0, 0, 1 here, now that I have the zeros where I want them in row 3, I'm also going to fix the sign on that. So once I get down to the zeros and ones the way I want them in this part of my matrix, that's when I actually worry about making it a positive 1. Okay, so this is supposed to be my new row 3. Let's see, what was this? This was my new row 1. So believe it or not, when we get to this point, we've already fixed column 2. We're just going to rewrite our matrix again because we've got those zeros that we identified that we needed in column 2. And then we're just going to have one more. We've just got one more column to worry about. So here's our new row 1. Our row 2 is staying the same. And we've got our row 3 that's completely finished because it's 0, 0, 1. All right. So at this point, I am looking in column 3. So that I know in column 1, this is a -2 instead of a 1. We do not worry about that until we have all the zeros we need. So first I need to get a 0 here. And then in row 2, I need a 0 there as well. Then I'm going to worry about fixing that first number. So our first priority is getting zeros. So I am going to have to take, I guess it'd be really easy. I need to use row 3 for everything, right? I need to use row 3 and row 1 here. So row 1 plus row 3. If I used, in order to cancel out this -1 here, if I used row 2, I'd be introducing something back into the middle. And so I don't want to do that. So I'm going to use in order to cancel this, I'm going to use row 3. In order to cancel this 1, I'm going to use row 3. So hopefully our Gauss-Jordan elimination is improving. I'm finding for my students, it's a lot easier now today. But we have had a chance to practice. And some of this stuff, it's not that it's difficult. It's just that we have to practice it. All right, so at this point, I have the 2 zeros that I need. So I'm going to do something about this -2. And this works out really nicely because I can see how if I divided everything by -2 or multiplied it by a -1/2, I would have no fractions here. And that's why I wanted to wait until the end. I'm multiplying by a -1/2, so this will be a +3, -3, +1. And this is now going to be my new row 1. So that's all fixed. And instead of going up to the top of the page, I'm going to put this over on the right here so I can kind of fit it all on the screen together. So now I'm going to have to use row 2 and row 3. So I'm going to use a negative of row 2 and add row 3 to that. So let's see, that'll be 0, 2, -1, 0, -1, 0. And then my row 3 the way it is. And then we'll add those together. And then again, I can multiply everything by 1/2. So we are making this a 1. We're just not worrying about it until the very end, because then I don't have any fractions. If I'd done that at the beginning, I'd have to work with all of those fractions. And we don't want to do that. The numbers just kind of take care of themselves. So this is going to be my new row 2. And then I am going to have to move my paper here so that I can go back up to the top somewhere where I've got space and rewrite those matrices. So I'm going to rewrite this now, given all of our new information. So our first row is now that 1, 0, 0, 3, -3, 1. Let's see, our second row is 0, 1, 0, -2, 2, -1. And I don't like this isn't lined up very well, so let's kind of move that 1 there. It's really important that we have this neat. Otherwise, it's so hard to follow what we're doing, even if it's the very last step. So now let's kind of remember what we were doing. We started out with our original matrix and we augmented it with our identity. Now our identity is over here. So this is now I, and this is now going to be my inverse matrix. So my inverse matrix is going to be what ended up where my answers go. And I could verify this. if I wanted to, we could verify by showing A times our inverse matrix equals our inverse matrix times our original A again, which just equals the identity. So we could verify that if I wanted to. And I think this problem has been long enough. We don't need to worry about that right now. So in the back, we're going to look at determinants. And I'm not going to give you a lot of information about determinants today. We can use our determinants, and we will for a 2x2 matrix pretty easily to find our inverse. Determinants we notate when we talk about finding the determinant of a matrix. When I find the determinant of A, I'm going to do that by putting what looks like absolute value signs on it. And the way I get my determinants is by multiplying my diagonals. So when I do this first diagonal from left to right and it's going down, that's going to be my positive diagonal. So -5 times -8. So we're multiplying along the diagonal. And then the other one, the other direction, I'm going to subtract. So this is going to be our determinant of A that we're finding. So we're multiplying this first diagonal and we're subtracting the second one. And that's going to be 40 minus 40, which is 0. So the determinant of A is 0, which actually means that there isn't an inverse on that one. So sometimes you can't have inverses. This would be invertible because we can't take an inverse. And we'll look at kind of why that is in just a second. On B, when I go to do my inverse, I need to do the same thing. We're going to multiply on this diagonal. And then when we figure out our other diagonal, we're subtracting it. And I know that I have a minus negative here, but I just write it down exactly the way it is. And then I fix it. This is going to be a -12. Now I'm going to write plus 16 is 4. So the determinant of B is 4. So if A is a matrix, A, B, C, D, then this is my determinant. My determinant is AD minus BC. And the inverse is 1 over the determinant. So you can tell, like, that's why it doesn't work for that first one, because our determinant is 0. 1 over 0 is bad in math, right? Times, this is not what I meant to write. And this is going to be scalar multiplication times. We take our original matrix and we swap on this diagonal. So it's going to be DA instead. And then this is now a -B and a -C. So if I was going to find my my inverse of matrix B, it would be 1/4, because my determinant's 4, of 6, -2, and then this would be a -4, and this would be a +4 now. And then scalar multiplication, I just distribute that. So I'd have 3/2, -1, 1, -1/2. So if I multiplied these two together, B and B inverse together, I would get my identity matrix. So that's why we might care about a determinant. We're looking at a determinant now for a 3x3 matrix. And this is a different method than Glencoe. It's way better than Glencoe. And what I need to do is I need to have, like, in a 2x2, I had these diagonals that had 2 things. In a 3x3, I'm going to have 3 diagonals with 3 things. So the issue is I don't have 3 diagonals here. So I need to recopy the first 2 rows. Or first 2 columns. I said that wrong. I need to copy the first 2 columns. And then I'm going to multiply these diagonals here. These are going to be my positive diagonals. And then I'm going to subtract the 3 diagonals in the other direction. So it's kind of like the other one. So 4 times 3 times 1. That's my first diagonal. 1 times 4 times -3. Plus 0 times -9 times 8. And then my minus diagonal, so minus will be this one right here, -3 times 3 times 0, minus the next diagonal, 8 times 4 times 4. And then the last diagonal is 1 times -9, 1 times -9 times 1. So now we've just got a super big math problem. So 12 plus -12, those are going to be gone, plus 0. We are so thankful anytime we have zeros with our matrix work. So, but this is a minus here, right? I need to change that. Let's see, it should be 128 minus, this is going to be a +9. So minus 119, that's going to be my determinant of A. So this is a different method than Glencoe. Glencoe has you separating this into a bunch of 2 by 2 matrices and looking at it. This is going to be a lot faster for you. So I would definitely get help on this if you need that, but I would use this over Glencoe's method. So this is the end of our part 2 6-2 notes.